So Adam says the probability that I choose 2 cherry sweets is 25 over 100. Where on earth could he have got that from? Well, he has calculated he's done 5 over 10 because that is the probability of picking 1 cherry sweet, but then he's multiplied it by 5 over 10. And that does give 25 over 100, but that's not correct because this second term is not correct. In fact, he has 1 less cherry sweet on the second pick. I'm just going to write in, I'm running out of space, but I'm going to write in the actual answer. It should be 5 over 10, and then there's 1 less cherry, so it's actually 4 of them, and there's 1 less sweet, so it's times 4 over 9. That is what the answer should have been. As long as you sort of, words to this effect, yeah, I think a good idea is to write down what the actual answer is because it shows that you understand the problem fully. Even if you just said it should be this, you're implying that you've understood there is 1 less sweet the second time around. But I decided to write a little sentence as well. Find the probability that the 2 sweets he chooses have different flavours. We could do this without a tree diagram, but I just think a tree diagram can help. So let's go for that. We've got cherry, lemon, and orange. And then I'm going to write down the probability 5 over 10, 4 over 10, and 1 over 10. And now let's say we picked, actually I can see why you might not bother with a tree diagram because it's going to be quite messy. Well, there's going to be cherry, but I'm not actually interested. No, what is it? To have different flavours. Oh, do you know what? I don't think I do it this way, but I'm going to keep going with this way now, and I'm just going to talk about a different way at the end. Right, let's go for in full. So if we chose a cherry the second time, it would be 4 over 9. The lemon would stay as 4, but now it's over 9. And then the orange would be 1 over 10. Sorry, not 1 over 10, 1 over 9. Okay, I'm just going to make my tree diagram a little bit strange because I want to be able to fit it in. So let's say he picks a lemon, but then he picks either cherry, lemon, or orange. Cherry now would be 5 over 9. Lemon would go down to 3 over 9. And orange would be 1 over 9 again. And then finally, for orange, we've got cherry, lemon, orange again. We'd have 5 over 9. We'd have 4 over 9. And actually this branch would not exist. So that is my tree diagram in full. If I want to work out the probability of picking 2 different flavours, well, often on a tree diagram, especially if you have more space, I would say label all the probabilities by multiplying them together. I'm just going to put the ones in that are important. So I'm not interested in cherry and cherry. I am interested in cherry and lemon. So I can multiply 5 over 10 by 4 over 9, multiply the tops to give 20. Well, I'm going to do this in a green colour actually. And then multiply the bottoms to give 90. So I'm interested in that because that would be this branch here. I'm also interested in cherry and orange, and that would be 5 over 90. Right, lemon and cherry I'm interested in because that's 2 different flavours. That's going to be 20 over 90 again. Lemon and lemon not interested in, but lemon and orange I am. That will be 4 over 90. And then if I pick orange, I can either get orange and cherry, which I'm interested in, that's 5 over 90, or orange and lemon, which would be 4 over 90. So I can add all those up. Actually, I just add, the denominators are all the same, so I'm just going to add the numerators, 25, 45, 50, 58. And you don't have to simplify these fractions for probability questions. 58 over 90 is the answer. Now we can do it quicker, so I'm just going to talk about that. The tree diagram, you might be someone who really likes drawing tree diagrams, but it is important in probability, especially later questions when it's gets really complicated, or the questions can ask, you know, what's the probability of not rolling such and such, and you need to be able to kind of just deal with probabilities. So I'm going to deal with it like this. I'm going to deal with cherry and then not cherry. Now the probability of me picking a cherry is 5/10, and then if I picked a cherry, I'd have 4 left, but I'd still have 5 that are not cherry. So on the second go, it would be 5/10, and that gives me 25. Sorry, that should be over 9. Right, I'm just going to say that again. Cherry and not cherry. Probability of me picking a cherry is 5/10. Probability of me then not picking a cherry, well, there are 9 sweets left. I made a mistake the first time round. There are 5 that are not cherry because there's 4 lemons and 1 orange, and I multiply that together, and that'll give me 25/90. And that is essentially me getting these two here. I've just done it more quickly without a tree diagram. Let's do lemon and not lemon. Well, the first time round it's 4/10. The second time round, well, I've got 5 cherries and 1 orange, so it's going to be 6/9. And that'll give me 24/90. And that is me working out these two essentially and adding them up. And then lastly, we've got orange and not orange. So the probability of picking an orange is 1/10. And then actually that's the only orange and it's gone. So there'll be 5 cherries left and 4 lemons, and it'll be 9/9, which is just 1. So I'll get 1/10. I think I'll leave the denominator the same though, so I'll write it as 9/90. And if I add these up, I'll get 25 plus 24 is 49. Add my 9, that gives me my 58. I get 58/90 again. So in some sense, this seems a little bit more confusing, but it's very quick. If I can just sort of understand that and get my head around the not cherry bits, then I can do this question in a very quick time, whereas otherwise I have to draw my tree diagram, work these out separately. It takes a bit more time. Whichever method you are happy with, go for it. Later questions you'll get major advantages from this, so that's why I do particularly talk about it. But yeah, 58/90 is the answer.